Dear students, now our aim is to derive the second equation of motion. We have already derived the first equation of motion. So this is what our aim is to derive. S is equal to ut plus half at square using the original 9th standard method. First of all, 9th standard we studied this way using graphical method. It's called as graphical method. In this method there was x-axis, which is time axis, and y-axis was velocity. The body started with initial velocity u and went to a final velocity v. The area under the vt curve is called as the displacement. Okay, and this is well known to us. Actually, in maths also, from 8th standard, there was this thing called as speed is equal to distance by time. Actually, this comes from the same thing. The concept is the same. But this is not what we're going to do in 11th standard. In 11th standard, which is intermediate, AP intermediate first year. AP intermediate first year. This is an 8 marks answer for them. And in 11th it is 5 mark answer. We are going to derive it using calculus method, which is integration method basically. How are we going to do that? Calculus method. Our aim is to find out this, derive this. S is equal to ut plus half at square. This is our aim, to be proved. We can call it as to be proved or solved. So, coming back to our well-known definition of acceleration, A is equals to dv by dt. If you observe this, and we already derived v is equals to u plus at. Using these two equations only, we can derive this. How? You see, displacement S is, by our basic common sense, what should be, just not get confused, this is S and this speed is different. Speed is totally different. This is a mathematical quantity. This displacement, fortunately in physics, it is actually denoted by small s, but this S is not speed at all. Okay, so this S is displacement S. We can put a script to it. In some lecturers will put a script to it. Script. So it is not S, it is something like S script. Okay, so from the basic knowledge of speed is equal to distance by time. So distance must be speed into time, is it not? So using this basic common sense, we're going to use the common sense here. But here this speed is here velocity. Which velocity? It cannot be u, it cannot be v. So it must be average velocity. And into, there must be time, into time. This is one way to derive displacement or distance also. But here we're going to use integration method. We're not going to use this. This is only for the logic part. So we're going to derive it using integration. How? See, if you see this, A is equal to dv by dt, by the same logic, v is equals to dx by dt. This is also taught to us. What is dx by dt? So if you integrate it both sides, we integrating this both sides by time. So what will we get? V dt integral over is equals to integral dx. Is it or not? So this is where the whole story starts. It's so easy from here. What is our time coordinates? 0 to some time t. Where are x1 to x2? This is x initial. This is x final. What is x final? Simply, as I told you in the first lecture, This x1, x2 are nothing but a point A to point B. The body has gone like this, like this, like this, and this is our displacement, shortest path between the initial and final points. So this is our x. This is actually, this A is nothing but, if you put it on the x-axis, this is your xi or x1, this is your xf or x2, what we can call it as. Okay, so these are the things here, x1, x2. We're going to integrate it over this line, or over this curve. It makes the same because it's a vector quantity. So we got to integrate that. Now here is the biggest problem. How do we integrate this v dt? V is not some number, we just can't take it out like earlier we did that. A dt, if you remember, when we integrated this part, a is equal to dv by dt, then what happened is a dt, a used to come out and integral dt was simple t. But here it's not going to be like that, because v is a function. V is a function of time. So what is that function of time? We already have it. This is the function of time. V is equals to u plus at. It's having time as an intrinsic variable. It's called as intrinsic variable. So we're going to substitute it here. Instead of v, we're going to put u plus at in brackets, dt outside the bracket, and the limits are 0 to t. And this is the RHS. And what is going to be LHS? Simple dx, as I told you in the earlier integration, integral dx is equal to x, simple, within the limits x1 to x2. It will be simply x2 minus x1, which is your s, displacement, script s. So it's it, that's it, we're already done with it. If you do this, it is s. So on the RHS, I'm going to write LHS as RHS and RHS LHS just for our simplification, for easiness. S is equal to, if you do this, it splits up. The integration can be split up as u dt plus a, integral a, t dt, from t is equal to 0 to t, from t is equal to 0 to t. Now what about this and this? U is a constant. U is a constant. A is also a constant. Well, everyone knows A is a constant, but what about U? U is also a constant because it's initial velocity. Initial velocity, like something like 20 meters per second or whatever. U is a constant. A is also a constant because the whole base fundamentals of one-dimensional motion is uniform acceleration. Uniform acceleration. Okay, that's fine. So we're going to integrate this in the next page. It's an easy integration. So here we come with that integration. Into s is equal to what is s is equal to integral. What is the first thing here? First term was, if you remember, at dt. If you see that, it was at dt and this is u dt. So I'm going to write that at dt. Okay, at dt plus integral u dt from limits t is equal to 0 to t, from limits t is equal to 0 to t. I'm just writing the first term, the second term, the first. So what will happen to this is a will come out, integral a t dt plus u will come out of the integration, integral simple dt. So what will this be and what will this be? T is equal to 0 to t, t is equal to 0 to t. Now this I have to teach a base formula for integration. Integral x dx will be x power is 1, then 1 plus 1 by 1 plus 1. That is because of the mathematics. x power n integrated dx must be x power n plus 1 by n plus 1. Therefore, the same thing applies here. That's why I wrote the first term in second and second term in the first, so that this is a new thing. This was not taught earlier. Earlier I only taught you that constant can come out and integral dt was dt. But I didn't teach you this, so I'm teaching you now. That's why I wrote this crisscross. Okay, does it make sense? Okay, so we're going to use that. S is equal to a comes out t dt, so t power 1 plus 1 by 1 plus 1 within the limits 0 to t, plus u comes out of the bracket as it already came out. Integral dt is simple t within the limits 0 to t. That's it, it's over. S is equal to a t square by 2, because it's t plus 1, 1 plus 1 is 2, 1 plus 1 2, ut. See, done. Written in our favorite way, ut plus half a t square. We got it, isn't it? Okay, thank you.